This is Keeper 3.3, Interpreting the Derivative. In this lesson, you're going to be taking different scenarios and like application problems and interpret the meaning of functions or derivatives. This is a script that you can use when you are trying to put into words a derivative or an instantaneous rate of change that's happening in that scenario. But think of what instantaneous rate of change is. It's a slope at one point, so at one x value. So it's the instantaneous rate of change, and then slope is your change in y at that x. So we're going to say the instantaneous rate of change in, and you're going to see what is the context of the y value and state it, when, and then look at what is the context of that x value and plug it in there, is, and then whatever the derivative is that's given to you, and you need to use the units that are within the problem. But the key is not to just fill this in, like the instantaneous rate of change, and put a word in there, when, and put a word in there, and then have a sentence that doesn't flow or make sense. So you use this script to help you to state the meaning of the derivative, but you need to clean it up so that it sounds good. It's a nice flowing sentence. Here's your first example to put in your notes. We have 3 examples. The cost of extracting T tons of ore from a copper mine is C equals F of T dollars. C is representing the cost. What does it mean to say that F prime 2000 equals 100? Okay, so we suggest that you always write out what your variables are in the problem. So identify what X and Y are in this situation. So that's step 1, identifying your variables. And in this problem, you look and you see it says F of T. So T is representing X, and it tells you that T is the tons of ore from a copper mine. So X equals the tons of ore. And in the statement that we're interpreting, it's 2,000. So 2,000 tons. And then Y is your cost, and it's the cost of extracting your ore. Okay, so we've identified the variables. So now we're going to think about our script and fill it in. Remember, it does not need to be word for word. You do need to say the instantaneous rate of change, which we'll use as IROC, I-R-O-C, and then the Y value. So the Y value would be the cost of extracting ore. So it's the instantaneous rate of change in the cost of extracting ore, but you want to say how much ore, and in this case the X is 2,000 tons, and then you want to say what the derivative is 100, and use the units, dollars per ton. So I kind of talked through it, and then this is the statement cleaned up. We won't have it exactly the same, but it's the instantaneous rate of change in the cost of extracting 2,000 tons of ore is $100 per ton. So you have the IROC, instantaneous rate of change in Y. That's the cost of extracting the ore. But then you want to say when you have 2,000 tons of ore. And so that wouldn't sound as well, so we just put it all together and say the cost of extracting 2,000 tons of ore is, and then your derivative, what it equals, $100 per ton. Example number 2. Suppose P equals F of T is the population of Mexico in millions, where T is the number of years since 1980. Explain the meaning of the statements below. So we have 3 different statements. You need to pay close attention to each one. The first one is just F of a number. So that's just talking about a point. The second one is F prime of a number. So that's talking about the derivative at a point. And then the third one is F to the negative 1. So that's talking about the inverse. So you got to remember that the X and the Y values are switched there. So when we get to each one, we need to pay very close attention to the notation in the function. So to start, we want to define our variables. In this case, X is represented by T, and it's the number of years since 1980. When you're writing your statements, don't say 5 years since 1980. Say 1985. Y is the population of Mexico in millions of people. Okay, so our first example, F of 5 equals 15. So we're talking about this function, this representing population. Our X is 5, so that's 5 years since 1980, which is 1985. And then that equals 15. So the population is 15 million people. This is not a rate of change. So we don't need to say people per year. In 1985, the population of Mexico was 15 million people. That's all you have to give for this statement, since it's a point and not a derivative. It's really important in this first example and also in this second example when we're just looking at the function and we're not looking at the instantaneous rate of change, that you give the statement in the order that the information is given to you. So we see the 5 first, which is the X, so you must discuss the X first. This is one of those things that College Board is picky about on the AP test. That doesn't apply with the derivative. With the derivative, this next one, you want to talk about the Y first because it's slope, and that's Y over X. So the second example, this is the derivative, so it's an instantaneous rate of change. So we know that we're going to start our statement with the instantaneous rate of change, or the IROC, in the Y, which is the population of Mexico in millions of people, but we can go ahead and say what the millions of people is in this case, and it's 2. And our time is 6 years since 1980, so 1986. So that's all of our information, and you want to clean it up into a nice statement that makes sense. So this is what I have for us. The instantaneous rate of change in the population of Mexico in 1986 was 2 million people per year. So we have the instantaneous rate of change. We have what our Y value is, population in Mexico. And then we need to talk about our X value. So that's in 1986. And then you'd say is, but it's past tense. So was the derivative, and the derivative is 2. And the units are millions of people per year. And then our last example, this is an inverse. So remember our X and Y values are swapped. So this 95.5 represents the population of Mexico in millions of people. So 95.5 millions of people. And 16 is now our X. 16 years since 1980 is 1996. Again, we're talking about the function, so we need to talk about it in the order which the information is given to us. So for this one, we're going to talk about Y first because we see it first. So Mexico had a population of 95.5 million people in 1996. We discussed y first because it was given to us first. The middle example is a derivative, so that's the change in y over the change in x, so that's why you're talking about the y and then the x value. Okay, this is our third and final example for your keeper. A rod of length 12 centimeters, it is heated at one end. So it's a 12 centimeter rod. The table below gives the temperature T of x in degrees Celsius at selected number of x centimeters from the heated end. So I thought that was worded a little strangely when I first read it, but you're heating this rod on one end. X is how many centimeters we are on that rod length away from the end, and T of x is the temperature taken there. So when x is 2, it means you're taking the temperature 2 centimeters away from the heated end, and the temperature there would be 71 degrees. So we're going to use the table to approximate T prime of 8. So that means that we want to find the instantaneous rate of change of the temperature when you are 8 centimeters away from that heated end. The temperature is not given to us in this table, so we're going to use the x values on either side of 8, which are 7 and 9, and we're going to have to approximate with the slope formula. So we're going to use 760 and 954 to approximate the slope. And that is going to give you the slope at 8 centimeters, but we want it, like, since it's changing, it's the instantaneous rate of change. And so we're having to approximate, we're saying this is an approximate. And you'd simplify that, and you find that it's approximately -3 degrees Celsius per centimeter. So remember, you've got your units for y over your units for x. So now we're going to take this information that we found and interpret what that means, like you did on the other two examples. So identify your units again. So we already talked about that x is the number of centimeters from the heated end of the rod, and that y is the temperature in degrees Celsius. So then write your statement. So we know it's the instantaneous rate of change, and it's a rate of change in temperature. You don't have to say degrees Celsius here because you're going to say it at the end. So instantaneous rate of change in temperature when, and we got to say what's happening with the x, so that the rod, I'm going to go ahead and write this out, is heated from one end. And then you want to state the derivative, which is, you're not going to say negative, you're going to say it's decreasing, and you need to say approximately 3 degrees Celsius per centimeter. If you just plug those words into that script, it really doesn't sound like a cohesive sentence. So this is rearranged to make it a little easier to understand, and you may come up with something that sounds even better. The instantaneous rate of change in temperature when the rod is measured 8 centimeters from the heated end is decreasing at approximately 3 degrees Celsius per centimeter. So again, our answers can be slightly different once you get to the homework or the test, but it needs to have all of the basic information, and you need to talk about the y before you talk about the x, and then you state the derivative, and you need to have the units.